Hello and welcome everyone. Uh, there we go. Welcome everyone to Microbit for Beginners. This is a 2-hour workshop at the beginning of 2025. If you would like to follow along with the slideshow, we have a link for you, and I am on my way to chat to share that. Paste. Okay, so there is a link to the workshop. And this, I'd recommend saving this link because there's going to be links to quite a number of resources embedded in this slideshow that you might find yourself at some point wanting to revisit. So, so hold on to that link. Now, since I'm sharing my screen, your screen is probably pretty filled up with the slideshow. If you are wanting to repeat the things I do with your microbit or on your simulator, you might want to be able to get in and out of this full screen view. And to do that, there's a view button up in the upper right-hand corner. And when you click that view button, you can exit full screen, and then this Zoom presentation will become a window that you can move around and resize so that you could, for example, put a browser next to it. We'll be using a couple of different browser-based programming environments for the microbit today. This is an example of, all right, here is the Zoom meeting on the left, and then here is a browser-based, in this case, Python programming environment on the right. So today we're going to start with introductions and overview. Then I'll show a little bit about setting up your microbit, and it's actually quite easy to connect your microbit to a computer and start programming. There's no special software required, so well, you'll see it'll be nice and easy. And then how to edit and save scripts, write block code, and Python. So that's two different programming languages. One will be the block code, the other will be Python. So for teaching programming at different levels, we'll show examples of both of those, and in concert with display and sensors that are built into the microbit. We'll also look at, aside from the microbit on its own for experiential learning, we will look at robotics, electronics, and cybersecurity options that can be used to expand what you're teaching with the microbit. And last but not least, I will show you where to find student and teacher resources. With you today are me on the left, Andy Lindsay, and on the right is Ari Alvarez, our company vice president at Parallax. So I'm broadcasting to you from Parallax in Rocklin, California, and Ari is up in Washington State. Parallax is a small business that has been doing electronics, robotics, and microcontroller education since 1997. So over 20, going on 27 years now. And they started in 1988. And our web address is parallax.com. Okay, so what is a microcontroller? That's going to be central to some of the things that we're talking about with the microbit today. And just so you know, a microcontroller is that programmable chip that has electronics connected to it, electrical and electronic circuits and devices connected to it that you'll find inside many common products. In fact, if you get up in the morning, you might press a button on your alarm clock. So the first thing you've done in the morning is interact with the microcontroller. If it's your phone, it's more of a supercomputer. But anyway, your microwave oven heating up, say, coffee or tea, water in the morning would be another thing where you're interacting with a microcontroller. It's connected to the circuits on the keyboard and the display and the little speaker inside. So when you press a button, the microcontroller is running a program that detects a change in a circuit caused by you pressing that keyboard button, and it will send high and low signals to a speaker to rapidly to make it give that sound that it makes when you press the button, and it'll also send signals to the display to update it. And so that's an example of microcontrollers, what they're for and how they work. They're also widely used in student projects. Now, these are some somewhat more advanced projects than the ones that students will be getting started with on the microbit, like the electromechanical millipede and the college drone project. And then this is actually a scientific research project, the Harbor Branch subs, where some parallax, basically parallax microcontrollers are used in all these projects down at the bottom here. So Parallax was founded by Chip and Ken Gracie. Chip is our chief inventor and Ken is our CEO. About me, I'm Andy Lindsay. My background is in electronics, and most recently I've been doing a certain amount of work with the microbit to expand the educational things that you can do with it. For example, plugging your microbit into a small mobile robot and programming it to work with that, and also setting up electronics lessons with the microbit. I'll show you a little bit more about all these later on, and we've got links to some of the, if you're interested in looking at some of the stuff that's been published for these, there's links. Like, for example, if we want to go to the online workbooks for the Cyberbot robot, you can click and follow the link, and you will end up on a screen where you can then enter the block programming version of the Cyberbot robot or the Python version. And so if I follow the block version, here is a list of, although they're called, well, I consider these to be chapters. And so these are like chapters in a book. And then we have an equivalent set for the Python programming language. All right. So Parallax got its big start with the basic stamp microcontroller. Before this, programming a microcontroller like this one on the basic stamp was pretty challenging. It took technical education or an engineering education to have what it takes. This was back in the mid-90s in order to program one of these devices and have it monitor and control circuits. These days, it's something that's done in middle schools and sometimes even earlier. Now, between the basic stamp and now, a number of microcontrollers have gained popularity in the meantime, and the most recent entry in that list for education is the microbit, which here is the top and underneath view of the microbit, along with an example of it plugged into the Parallax Cyberbot robot. Now, the microbit is a module that has microcontrollers on it, but it does more than just serve as a microcontroller that you can connect circuits to and program. Yes, you can do that, and these pads at the bottom are designed to, you can either connect alligator clips to the larger pads, the ones with holes in them here, or there's a whole bunch of small pads, and those, when you plug it into an adapter like this one, it can run all of those electrical connections to some other system like this robot controlling board here. Now, so it can be treated like just a plain old microcontroller that you can use for adding circuits, but there's lots of fun and engaging there are features designed into the microbit that students can program it to use those features for quite a number of fun and engaging exercises, and also lessons in a wide variety of topics, from programming to environment to, if you use these pads, the electricity and electronics side. But built into the microbit is a rudimentary display of 25 LED lights. It has a couple of push buttons. It's got a touch sensor, a microphone, a speaker on the other side. Built into it is a radio so that microbits can all talk to each other over a network. And that network is a network that is on the same radio frequency as, say, Bluetooth and Wi-Fi, but it does not interfere with either of those kind of devices. And in fact, you can program it over Bluetooth if you're using certain tablets. But they can also, again, they can also communicate with each other through those radios, which is pretty neat. It's got a battery connector reset button, and then most of the programming that we'll be doing today is through this USB port. Additionally, there's a little chip here that has a compass and an accelerometer built into it. An accelerometer is a device that measures tilt and can also measure things like vibration and rapid motions. And it's the thing that allows your cell phone to detect when you've turned it, so it can rotate the display so that you can still see it as opposed to having to tilt your head. Let's see, I think that pretty much wraps it for the features of the microbit, and students can write code to integrate these features into quite a number of applications, which we'll be getting to shortly. Okay, so I'm looking for another slide here. I just wanted to mention just a couple of a few examples of applications, very simple ones like a beating heart, where you have a large heart and then a small heart and then a large heart again. Writing a script to display that is something that students can do. And in doing so, they get to learn about how a script or a program can repeat certain elements in code. An emotion badge is another example. And in this case, if you press one button, you might send a smile or display a smile. And if you press another button, you might see a frown on the display. And this is an example of lessons for conditional statements, those being, well, if the button is pressed, then if the A button is pressed, the one on the left, then display a smile. Otherwise, if the B button is pressed, display a frown. Sunlight sensor is pretty neat. These LED lights can also function as light sensors. And the accelerometer is in use in this one as a step counter. There's also, as I mentioned, the compass. And so you can even have activities where you're following the compass. And then send a smile is one where you press a button and it sends out a smile over the radio. And any microbit in the neighborhood that is configured to the same channel and group as this microbit is on will be able to receive that. Okay, so coming back to today, that pretty much takes care of the introductions and overview. So next I would like to talk about how to set up your microbit. I just want to make sure everybody knows the right place to go, and essentially the hurdles, or I want to make sure that there are no hurdles for you getting your microbit set up. And so Here are the two different programming systems that are most common and easiest to set up. One is this make code block editor, and the other is the microbit Python editor. And let's see, I guess probably the best thing to do would be to talk about the make code block editor first. And so I'll go ahead and chat you the link for that editor, and then the link to the getting started instructions. And I see a question in the chat. The question is,
the questions are about the colors on the microbits. The teachers notice that sometimes you have a yellow, a red, and blue, and they were asking if it has any meaning.
yes, well, it does in a way. For example, okay, so here is my blue microbit. And when I'm using that to control a robot, I chose a blue microbit for the robot so that I could know that this was the one I could tilt to control this robot. And then I also have a yellow microbit and a yellow microbit on a robot. So essentially, it's color coding. Functionally, the microbits are no different. Though there are versions of the microbit. You can look at the back, and it's going to be really difficult to see, but there are some very small letters in this corner that will tell you what version of microbit. The common ones are 1.5 and 2.2. And the microbit 1 has a few less features. For example, it doesn't have a microphone, and it does not have a touch sensor. It's also got a little bit smaller program memory. So if you're doing a larger script for this microbit, you might find yourself having to make sure to write more efficient code for the microbit version 1. Okay, coming back to the make code block editor. Let's go ahead and just open up the introduction, and I'll just kind of talk a little bit about how that getting started sequence works. Okay, so here we are at the introduction, and there's a nice little introductory video. And so what they have here is, if you're taking the microbit right out of the box, they want you to plug in the batteries and try pressing the buttons and see how that works first, and then go on to connecting it to your computer. And so if I follow that connecting it to your computer link, okay, so I'm going to go back just to show this again. So I'm going to follow the get coding link, which happens to be, I believe, right. So the power up and play is one example. And then the get coding is where you can really get started. And there's a nice little video that shows how to do things in make code, which I'll show you an example of in just a little bit. But what I want to bring to your attention to is that it says hit download. And the hope is that everything's automatic. But what I really want you to look at is there's a video inside that hasn't worked. I don't see a name on my microbit. The project, by the way, is to display your name. There's a really good video in here about sending scripts to your microbit. And so I just want to bring that to your attention that that hasn't worked. The video that's there shows you how it should work. And it essentially shows you how to Ari, is that audio making it through? Okay, so you cannot hear the okay, so you cannot hear the audio from the, let me see if
No, I will see if there's any setting.
You know, okay, and it's actually fine. I'll just kind of mention a couple of things. So it talks about which browsers you can use, and then it talks about plugging it in. So here's the thing. When you hit download, it's going to prompt you to plug in the microbit and connect it to the computer with USB. And then after that, the second pop-up that comes up has you click on pair. And when you do that, what's going to appear is a list of microbits. And you have to click that microbit and then click select. So I'll show you how that works. So along the way, that those step-by-step lessons in that site are going to have you go to makecode.microbit.org. And I'm going to back out to the main page. So you'll arrive here, and then you can create a new project. And then we come to our blank slate for the microbit. And so we can do things like click the basic menu of items. And for example, this one shows us a heart. And I'll zoom in on this a little bit. Okay, hopefully that's a little bit more visible. Just give me a shout out if it's not. So we can click our basic menu and select a couple of hearts and maybe a pause. We'll go ahead and increase that pause to 500 thousandths of a second, so we get half a second pause. And the top one is a full-size heart, and so we'll go looking for a smaller size heart. There it is. And then we'll need another pause. I just right-clicked and selected duplicate. So here's an example of a script that should, if I send it to this microbit here, it should stop doing its hello and then displaying a heart and instead display a beating heart. So when I hit download, or I may need to hit the three dots to, oh, for some reason I already have it connected. So I'm going to disconnect and just make it like, okay, we're getting started for the first time here. So I'm going to plug in my microbit and then hit connect device. And here's where it prompts me to plug in the USB, which I already have. And then we'll hit next. And it's going to say that it wants to pair it to this browser. And so when you select pair, and this is what it talked about in the video, the tricky part is that this window comes up and students won't be able to click connect until they select their microbit from the list. There's only one microbit listed there, but you could conceivably have more than one connected, in which case it would list them all here. So you have to select your microbit before clicking connect. And that now we're connected. And so I can, I hit a button on the side of my mouse. Let's see if we're still connected. Done. Okay. So now when I hit download, the screen goes blank, and now it's displaying that beating heart. Um, and notice also that the heart is beating over here on this left panel of the makecode.microbit.org editor. Um, and this is a nice simulation. And we have options to, for example, stop the simulation, restart the simulation. There's even a little debugging environment. If it's programmed to play sounds, you can play a sound and take a screenshot and then even view this as a larger screen. So this is a really nice little simulator here. And then there's other categories. For example, if we wanted to add radio communication in, well, here's the blocks for radio communication. If we want to play some music, here's the blocks for music. So lots of good stuff for the students there. And that's an example of getting started with the make code block programming environment. See if I can make that menu disappear again. There we go. Next up, I'd like to talk about getting started with the microbit Python editor. So I'll copy that link address and paste it in. And then also here is the get started. Here is the get started link for the Python environment.
Andy, we have a couple of
All
questions in
right.
the chat, and I was going to answer in the chat, but
Oh,
you may want to say that in the recording.
yeah, good point. Okay. So the first question I see is, let's see, wow, there's a lot of talking going on.
Well,
Which one would you like me to start with?
is there a way to pull programs off the microbit?
Not that oh, actually there is a way. Um, I'm going to go
I
off
was going to
screen and
say
do a
no, but
search.
I think there's a really hard way. Not
Yeah,
easily,
I mean
let's put it
it's
that
kind
way.
of a yeah, it's listed over on tech.microbit.org, which is the developers page. But let's see, I'm going to type in a search off screen. Is there a way to pull a program off the micro bit question mark? Okay, and so here we go. AI says yes. Um, and let's see. Um, okay, so this is giving a step-by-step from somewhere on the web, but there should be a tech.microbit.org link. Here we go. So, well, this is forums.makecode.com. Huh. Well, we'll follow this one. That should be fine. And so somewhere they should, here is finally the link that that I was thinking about. So how do you get so the U bit, because micro is abbreviated with the Greek character mu, which looks kind of like a U. So that's why they have the U bit tool. So I'll go ahead and paste this into the chat. Boom. All right, so that answers that. And so yeah, it does, it requires some software installation, I think. I think the UBit tool is, yeah, it's an application. It looks like it's something you'd have to install on your computer. Okay, next
And
question.
kind
Go
of
ahead.
related to that is, can you have more than one program on the microbit at a time?
Um, there might be a way to um, yes and no. Um, you're really only running one script at a time, but you can store configurations inside the microbits onboard memory. But normally, um, and you can also add strings to a program in Python, and those strings can actually be converted to code. So I think I'd like to give you a link to that. Let's see here. So I'm going to learn.parallax.com, which is where many of the lessons that we'll be looking at today come from. And then if I go into any of the Python language lessons, so I'm just going to pick Cyberbot because that's the most complete offering of lessons. And then, for example, cybersecurity is a subset of it. And then going to strings and characters primer, and then way down, continue to go to all the lessons. So here are the lessons, and way down at the bottom of the strings and characters primer, it shows how to write a script that in this case allows you to enter code into a terminal, and then whatever you enter, the microbit will execute. So that's another way to have multiple programs, is to simply store them as scripts inside, or as strings inside your main script. And then that way you've got these subscripts that you can run. Okay, what's next?
That was all.
All right. Okay, excellent. So next up, we were in the midst of, did I paste the link for getting started with the microbit?
Yes.
Oh, thank you. Okay, very good. So, so we'll go ahead and show you how that getting started process looks like for those of you who are thinking about teaching Python, which, by the way, is a really popular language. For example, if I did a search of what are the most widely used programming languages for robotics, so C and C++ is still number one, but a close number two is Python. And I wouldn't be surprised if you, oh, well, it just says C++ as the number one. But Python is number two. However, it's way easier to learn than C, and students tend not to get as mired into all the little syntax features that can trip you up in C language. So as a first language before C, I definitely recommend Python. Python, here we see that it's a language that they can extend to their real world. In this case, Python. And if I did a similar search for the sciences or other things, Python is always going to come up. So it's a really good language for students to know, regardless of what job direction they might end up taking, in at least in the tech world. Okay, so here we are at, and again, this link that I'm at, the Getting Started with Python, or the microbit in Python, is this big link right here. So editor and get started link for make code, editor and get started link for Python. And this is the cover to the course, and it shows, hey, you need to have a USB port on your computer, and if it's only a USB-C port, then you'll need a little USB-C to A adapter. And then we can continue, and then there's a nice video that takes you through essentially everything. Now we won't have any sound here, but that's okay. I just want to show you that this video exists. and it shows you and the students how to say use the simulator and write a program. And then later on, it shows how to connect the microbit to the computer. And then later on after that, it shows, okay, here we are writing sorry, there's a pre-written script that is that we're loading into the microbit that comes when you open the editor. And then it talks about how to change that script a little bit to something different and then load it into the microbit again as a modified script. And then it goes on to talk about so that's how to load a script, how to make changes to the script, how to save and edit scripts, and all this. Each one of these has a video that goes with it, just like this first one for flashing or loading a script into your microbit. And immediately below the video, there are checklist style instructions so that students can, for example, hit play and pause and follow the video, or they can follow along with the checklist instructions and image screen captures below it. And so just to show you an example of how that works, let's see, I'm going to close this microbit editor and just sort of start from the beginning. The tutorial has you go to python.microbit.org, which I pasted in. And then here is the simulator on the right. And so, for example, you can see the simulation of display.show image.heart. And then, so there's the heart, and then it displays the heart for 1 second. After that, it scrolls the hello message across the screen as it's doing right now. And this is a little bit simpler of a simulator. It's just got play and pause. But it also has all the little things you might need for, like, to simulate pressing a button, or to simulate brighter light in the room, or to simulate that you clapped your hands, and to simulate shaking the microbit. All right, so I'm going to switch over to my going to disconnect from make code. Okay, so I click the 3 dots and select disconnect. Now I'm unplugging that microbit and then plugging in my microbit that I'm using for Python. The reason I'm doing this is because it takes 30 seconds, which feels like an eternity when I'm presenting, to wipe out the make code environment and then put the it's an automatic process. It's just that the progress bar takes 20 to 30 seconds to put the new programming environment for Python over the existing one for make code. So I have a Python one that's ready to receive a Python script because it's already got its Python runtime, and then the other one is for the make code. So here we are in Python, and right now it's displaying a smile, but over here it should display a heart. And so when I hit send to microbit, it's the same process of having to select your microbit and then hit connect. And then there we go with the heart and the hello. So that is how the microbit, how a script can be loaded into the microbit with either language. Okay, next up we have editing and saving scripts. In the make code environment, if you're using the same computer, it will remember your projects. But if you want to save them to, say, a flash drive, what you'll need to do is, if you're in a project, you want to make sure that you are not connected. So it's currently showing me the option to connect the device. Well, that means it's disconnected. If it gives me the option to disconnect, I could disconnect. And actually, I think you can just hit save even if it's connected. So there's a little save button down here, and it'll essentially plop it into your downloads and tell you that it downloaded a script. All right, so let's going to bring up my file explorer and go to downloads off screen. And shift start plus. Okay, Ari, did that make the screen appear larger on the receiving end, or did I just zoom it in for myself? Because I'm looking at things and they look very large to me now.
They look very large here.
Okay, excellent. So the zoom in did work. Very good then. Okay, so here is the script, microbit example project.hex. So when I hit save, it downloaded to my downloads. Now, if I change this script, for example, I'll right click and delete that block. So now it's just going to show me a heart with a 1 second delay, and then repeat that forever and ever, which isn't very exciting. Oh, need to make sure I've got the right microbit on here. So I'm going to hit the 3 dots next to send a microbit down on Python and disconnect. The reason I'm doing this carefully is because sometimes things get a little weird when I'm on a Zoom meeting and doing this. So I just make sure to tell the browser that the microbit is disconnected before I disconnect the microbit. Usually in practice, it works out just fine in the classroom if the student unplugs the microbit. But again, since I've got 2 different microbits going, things can just get a little weird. So escape. Well, pair. Okay. So so now it's loading the script, and now the heart is just sitting there. It's not beating. So just to show how I can go ahead and open a new script. Let's see here. Home. I believe it's import. And then import file. So choose from files on your computer. And then I'm going to choose a file from my downloads. It's that first one. And we are back to the beating heart, which I'll go ahead and load into my microbit. And now I'm back to the beating heart on the video display. So that is how to save and open in the MakeCode editor. Disconnect. Now let's switch over to the Python editor. And it's the same thing there. Basically, here I have a script. So I'll go ahead and hit save. And this is covered in the videos in the introductory page. But let's see. Heart and hello. Confirm save. Close. And it, I should have mentioned, it did download that. So heart and hello is now in my downloads. And so if I refresh my downloads over here, we can see the heart and hello hex file. And if we go back out. So if I change this to happy and hit send to microbit, need to pair with it. And then now we have happy and hello. And if I want to open the file that I saw saved, I hit open and you basically get your same file open dialog, and we're in downloads, and here is heart and hello. So it's displaying a smile. If I open this and run it, I haven't saved my current file, but that's okay. Now it reopens to the file I saved, and it'll simulate there, and I can also send it to the microbit. And that is how it works in the Python environment. So that is saving and opening files. And this is a recap of that. So here it is in the make code editor. And then here it is in the microbit Python editor. So these are all links to, this is basically what the contents of that course, or chapter as I like to call it. Here's the same contents that is in the getting started with the microbit along the left here. Next up is writing block code and scripts that interact with the display and sensors. Okay, so the first and best icebreaker resource, I think, for doing things like that is microbit.org/projects/make-it-code-it. And make-it-code-it is separated by dashes. So here is the link to that. And any of these links will take you to specific pages on Make It Code It, but I'd like to start with just going to the home page of Make It Code It. And here we are. Let's get that little Zoom dialog out of the way. So the first one here is, if you think about programming as having, I think 5 major elements. There's communicate, remember, that's store and retrieve values, repeat, decide, and let's see here. Communicate, remember, I forgot calculate, repeat, and decide. What this does is it introduces, here's communicate, it's displaying a heart. Here's repeat, it's displaying a beating heart. By the time we get to emotion badge, it's deciding. It's deciding that if you press one button, it'll display a smile, and if you press another button, it'll display a frown. You can shake the microbit to do your own art. It's kind of like a modern version of an Etch-a-Sketch. And then as we go further down, there's more things introduced, like the step counter puts all those concepts together. It essentially repeatedly checks to find out if the microbit was shaken, and then it uses math to add 1 to the current count that it remembers of how many steps you've taken, and then it communicates by displaying that number of counts on the front of the microbit. So by the time we get down here, students have learned the basics of coding, and they can do that in either Python or MakeCode. So I just followed that step counter link, and there's a video and a coding introduction. And then as we scroll down, step 2 of code it, what I want to bring to your attention is that by default, it shows you the make code. But if you're using this to teach Python, well, all you have to do is click the Python tab, and then you will see the Python script. And then click the make code tab, and you can go back to the make code script. Now there's a classroom environment where you can actually have all your students join you in a virtual classroom where you can share your code with them, and you can also see how they're doing with their code. It's completely anonymous. Nobody shares any personal information. They're just assigned a particular anonymous name for attending the class. So there's no COPA concerns in this classroom environment. What I'm going to do is open and make code. And one recommendation I've got is that instead of hitting open and make code, which will open it in another tab, well, then you might have more than one browser tab that's trying to connect to the same microbit. I recommend right-clicking and selecting copy link address, and then going to your one make code tab, and then pasting that link address in. So right click and then paste and go to the link address we just copied. And once I've done that, here I have, let's zoom in on this one here a little bit. So basically on start, set steps to 0. That's remember. Then this is an automatically repeated block, this on shake. So basically, if it's shaken, and then this is automatically repeated. So this is both decide. Well, I decide that I detected that the microbit was shaken. Then I'm going to do these things. And then the on part is basically implicitly repeating all the time and checking to see if you've shaken the microbit. So that is our repeat and our decide. And then change steps by 1 is the calculate, and then show number of steps is the communicate. So by the time we've gotten to here, we have all the different little pieces of the coding basics put together. And so if I want to run this, I've got the wrong microbit connected. So Python environment, 3 dots, disconnect, and then back to make code. There we go. So I just need to connect. And remember, keep in mind that you won't have to do this every time. This is just something I do since I'm demonstrating 2 languages. Your classroom students can just leave their microbit connected, or usually they'll be able to disconnect and reconnect, and it'll automatically pair again. Okay, so I'm ready to go here. We'll go ahead and send to microbit. And it's not going to show me anything straight away. Okay, there we go. But when I shake it, the accelerometer will do all those things I just talked about in the script. And each time I shake it, it's going to increase the number of steps that it communicates to me by 1. So there's an example. Now, if your students are doing it in the Python world, there is also open in Python. Again, if you get everybody in the habit of copying the link address, or they can just copy the script and put it in there. And incidentally, I should have shared this link with you over the chat. So here is the link to the specific project, this accelerometer project, or this step counter project. Okay, so right click, open in Python, select copy link address, and then go to our Python editor, select paste and go. And that will take us to the pre-written code. Although it's not doing, is it doing it? No, it's not. Let's see. I'll hit enter. Huh. Paste and go. Okay, well, that's not working. So what I'll do is I'll close the editor and then go to the project here, paste in. So now I'm at the project, and here is the Python version. So if I hit open in Python, there we go. Now, another thing I should be able to do is, and so this is if accelerometer.was gesture shake steps plus equal 1, which is the equivalent, as you end up learning, of steps equals steps plus 1. I forgot my equals. Notice that I forgot my equals, so it's not really a valid statement right now. And there's a faint underline under steps and a little red dot. And so this is a nice way of being able to see that there's a programming mistake, a syntax error. And so once I add the equals that I needed, notice that there's no longer that heads up, you've got a coding mistake. And we can simulate this, and there should be a shake option. Let's see if I can, yeah, shake is already selected for the accelerometer. And so I can hit the paper airplane send button and notice that it increases the count. Or I can send to microbit. It presents me the list of microbits. Got to select your microbit and hit connect. And another browser tab is connected to the microbit. Close any other tabs. Okay, so this is what I was trying to avoid. Let's see if I can. Oh, it's because I had the wrong microbit connected. So hopefully now, and because I also forgot to hit that disconnect button over here. Pardon me. Hopefully I haven't gotten myself into trouble with that. We'll see if I run another make code example. Okay, so if I shake this one, each time I shake it, I get a new digit. So that is an example of getting started with really basic programming examples, and I picked one again that was way or a ways down in the list, where students had already presumably tried other programs, other examples, and along the way learned all the basics of writing programs, those 5 categories that I mentioned earlier. Let's see, do we have any questions so far? Just copied, pasted at work. Oh, good. Thank you, Julio, for the mention that you copied and pasted the Python code from the example into the editor. So like if we go back to beating heart here and hit the Python tab and then copy the code, it works. And then Control A, Control V. Try again, copy, Control A, Control V. Ah, okay, there's the paste. And then send to microbit, and we should have our beating heart. And so, yeah, that I think is probably a better way if you're just having students try examples. Now, microbit also has an improve it section, which you can use to verify that your students are adjusting the code so that they are putting their hands on the keyboard and the mouse and participating in the programming experience, because it's really easy to get in that gee whiz mode where nothing is learned except for the process of copying and pasting code. So whatever you do in your class, please add something to get your students to put their hands on the keyboard and to make it their own. Okay, so these are super simple resources. There is a deeper step that I want to share with you, and I'll put in both the both links here. We've got the paste. That didn't work. Looks like I might have forgotten to embed the link in the image. So I'm going to do writing microbit programs from that link over there. Paste. Okay, so that is the Python version. And then here comes the paste, the make code version. And let's get this fixed. All right. So this is a slightly deeper dive into coding for the microbit. And so it takes you to, in terms of LearnPress, the parallax site mechanics, it's called a course. So you might see this referred to as a course. I consider it to be a chapter. And when you go into the chapter, it has activities. And so there's an LED matrix activity. That's the communicate activity, or including scrolling, text, pre-made images, custom images. Then we get to the store and retrieve values, the remember part, the calculate part with the math problems, making decisions, counting and repeating. And then we've got also a little bit about the hardware aspect, that being the push button. So after you've learned the programming, how is that applied to pressing and releasing a button? And then it goes deeper into making functions, and then talks about global versus local variables. And if we go now to the, let's see here. Did I go to the Python version first? Let's see. No, that is the make code version. Okay, so now close everything to the right, and then now I'm going to go to the Python version and enter that course / chapter. And notice that it's the same subjects, just a different language. And here we are at scrolling text, and now we have Python text examples. But again, this is a deeper dive. It's going to have you try more different things. It has more explanations and then more challenges down at the bottom of any given lesson / activity. And it is currently 4:10. Let's go ahead and take a 5-minute break, and then we'll reconvene and talk about how the microbit supports experiential learning in coding, robotics, electronics, and cybersecurity courses. So let's see, it's 10 past the hour right now, so let's reconvene at 15 past the hour. Ari, could you pause the recording? Okay, so welcome back from the short break, everyone. Now we are going to look at some of the examples of how, beyond the basics of programming and having a physical thing that you can program as opposed to writing programs on the computer, we're going to expand that into a number of areas, including robotics, electronics, cybersecurity, and AI. Okay, so actually, look at this. We're starting with the AI examples. So the AI examples are primarily, one of the main purposes here in the AI lessons has to do with cybersecurity. And notice that for the prerequisites, the get started with the microbit, which we went through at the beginning, and then the writing microbit programs are required prerequisites. I believe that this one's only available in Python currently. So this one starts with just some, discussion of AI and chatbots and how they work. And then what it does is it next shows how you can actually ask a chatbot to write you a script for the microbit, and it'll actually do a decent job as long as the script is simple enough. But so the students will go through and they'll see, oh, hey, it wrote me a script, and they can run the script that was written and try it out, and then read through and they'll see another script for a beating heart, but this is not a well-written script. Let me zoom in. This particular script is kind of complicated. It's using custom images instead of the built-in images. And so the way the lesson goes is that we explain to the AI, hey, you can do a better job and use the built-in images. And so then it says, oh, well, thanks for pointing that out. And here is the script with the built-in images, and it works. Then we challenge the AI to write a tilt compass, which is something where essentially it's always going to point down, no matter how you have it rotated. Well, the microbit didn't do a great job on that. And to condense this whole idea of how it's how the microbit had trouble writing that script and how it needed somebody who understood the microbit and programming well enough is kind of you can't always trust what you get from chatbots and AI in general. You have to be involved in the process of development. You can't just say, hey, do it for me, and expect it to be perfect every time, because there are hallucinations. That's when the microbit when the AI just makes things up. And then also it can, do things incorrectly, as it did with this tilt compass. Well, it finally got a working tilt compass, and with lots of guidance at the end, we ended up with a AI generated tilt compass, and we might as well run that because it's kind of a cool little app. Send to microbit. Okay, so if I tilt it, notice that it's always pointing down as I tilt it. But again, it didn't really do a great job. And fortunately, we started out with a human written example, so we knew what we could get out of it. But another cool thing is it does lots of calculations that might be outside of what your students are ready to calculate. But it's kind of cool to see that the AI can do that kind of stuff. But yeah, it does provide a cautionary tale, and it's a very important cautionary tale so that students don't become overly dependent on AI. And that's actually the whole thesis of the AI book with all these chapters here. And we have one for the robot, and then also some cybersecurity issues of how both attackers and defenders in the cyber world are using AI to make more sophisticated ways of gaining entry to where hackers shouldn't be, and more sophisticated ways of detecting attacks for cyber defenders, keeping hackers out of their networks. So that is an example of AI with the microbit. And then let's talk about robotics with the microbit. So this cyberbot is really cool. You just basically plug the microbit in here, and then this example that I'm about to show you, and notice that here we do have a make code version and a Python version. And so each of these, if you click the image, it has a link that will take you to the cover page of the chapter on, in this case, tilt control, which is a ways into the okay, so here is, after running the script, basically there's a way to open up a console to send messages back and forth with the microbit. And so the microbit script is sending the computer, hey, print the message, enter left speed. And then the user is typing 100 for full speed on the left wheel side, and then enter right speed. And the user is in the midst of typing 100 there, and then enter the milliseconds, and there's a certain number of milliseconds, and all the microbits inside each cyberbot are being controlled by this one microbit here that's connected to the computer. So as the user is typing in that navigation information, it's being broadcast because the radio channel that this microbit is on is the same one that all the microbits in these robots are on. So, and then this microbit is programmed to get values from the computer and then send them out over its radio. All the microbits in all these robots are programmed to receive values from this microbit and then do whatever motion is prescribed here. And so each time something was typed, each time the wheel speeds and runtime was typed, then the robots executed their little maneuvers that corresponded with what was typed. Kind of a cool little application. And it's a little bit advanced, though. It's further into the robot tutorials. So we have here is the make code version. Yes, the tilt control. So let's see here. I'll give you those links. Let me back up here. And okay, so copy the make code link. So here is the tilt controlled chapter in make code. And then here is the tilt control chapter in Python. And so that's a really fun one. And it's for those of you who remember some of our earlier robots, the microcontrollers for those don't have built-in radios. So you have to buy something extra, and it's a kind of a separate project. So that's kind of a plus for the Cyberbot robot, is that the microbit has its built-in radio. And so, so this is possible without even buying any extra equipment. So here is the make code tutorials for the Cyberbot. And I want to emphasize that even though it says for the Cyberbot, I talked about diving more deeply into the code. And so the prerequisites section of the Cyberbot has the get started and the writing microbit programs that I talked about, this being a deeper dive, but it goes into even more coding with dictionaries and strings. And then it does the same kind of thing if you go into the Python version. You will see a similar table of contents where we have prerequisites. There's a little bit more here, and specifically exception handling. That's something we don't tend to see exceptions with the microbit, so I believe that's one that's not included in the make code blocks. So it's got dictionaries and strings and characters, but not exception handling. And then that is part of Python, along with strings and characters, dictionary, and so on. And so these tables of contents, I'll go ahead and copy and paste over to you. These, by the way, are all available all the time. These are really the student versions. I think I messed up that paste. Try again, copy, paste, and then copy and paste. All right, so those are the table of contents for all the robotic stuff. Just kind of a side note, it's already kind of neat because the microbit in itself is a programmable physical thing. So students get a more tangible response to the code that they write. With the robot, that takes it another step into the tangible response to whatever coding principle they're in the process of learning, by example. Here's an example from the tutorials where essentially this Python script, in this case, and there's a equivalent block version, this Python script basically is using the statements required to make it go forward at roughly 3/4 speed, and then do that for 4 seconds, and then pivot to the right for just a little over 1 second, and then stop. And so we have this code, and then the robot will go forward and turn to the right. Well, what if we want to do that 4 times to draw a box? Well, certainly a student could copy and paste this 4 times, and then they would have their box, but they'd also have some kind of sloppy code. That's not really the right way to do it. The right way to do it is with statements that make the straightforward and turn right code automatically repeat 4 times. And so now they have a much better program where they're using the features of the language in order to repeat something 4 times to get that box drawn on the floor. So that's an example of how robotics can, with the microbit, can further enhance students' ability to apprehend various programming / scripting concepts. The robot also has sensors. Now, again, I'm going to leave this to you. You've got the link to the slide, so you can go and click any of these tiles and follow the link to the make code or the Python versions of this. At any rate, inside the kit, there's a bag of electrical and electronic parts. And for this, the students built some whiskers that when they built and tested some whiskers that allow the robot to detect when it has bumped into something. Whiskers just touched the box, so it turned, backed up and turned, and then it hit the wall and backed up and turned. And so there's another example of in this case, sensors, and also a decision-making process. If one or both of the whiskers, its circuits has changed, the script will detect that and it will make the robot execute a turning maneuver. Also in the Cyberbot kit, there is a light sensor. So the robot's cruising along and then somebody shines a flashlight at it and it follows that flashlight beam and you can actually lead it around. And there's lots of good lessons built into this, both in terms of circuits and in terms of programming to figure out which side is brighter on the light sensors. The whiskers and the requiring a physical contact is not always desirable. So we also included parts for non-contact. So that detected the wall and the box before it even touched them. And so there's another example of some of the parts that are included with the kit and how they're used in applications. Then this is the tilt control. You saw tilt control. No, I didn't show you tilt control. Sorry, I might have left that out. Okay, so if we go to the Cyberbot, I'll just run into the Python. And so there's the keyboard control. So this is where the chapter appears for keyboard control. And right after it, there's a chapter that appears for tilt control. And that's the case in both the Python and the make code. And I just pasted the Python one in. And then here is the video of tilt control with the microbit. So if the person holding the microbit tilts it away from them, the robot will go forward. If they tilt the microbit toward them, the robot will go backwards. The microbit Go kit includes a battery pack, so that works really well for controlling the robot. And when they tilt it left and right, it will, of course, turn left and right. And I just posted one where students can use that tilt control in a robot sumo contest where they have the, where they put a pair of Cyberbots on the ring. They give each pair their own radio channel inside the script so that there's not crosstalk problems. So one microbit will control one robot, the other microbit will control the other robot, and then they can try to push each other out of the rings or out of this black ring in Robot Sumo. Another cool one is the gripper with tilt control. And essentially, the modification that's been made in the script is that now the buttons that are on the microbit can be used to open and close, radio transmit messages to make this robot open and close a sold separately gripper. So that was the buttons opening and closing the gripper, and then tilting it to move the robot around, tilting it left to turn in place, and then hitting the button to let go of the block. And then that's yet another chapter. This is a project, or we put these in the projects because essentially, if we look at the table of contents, okay, so learn.parallax.com, Cyberbot. I'm just going into Python, but I could have gone into either one. So these main lessons are what come in, use what comes in the stock kit. And then the sold separately products, as well as the class pack products, are included in here. So there's a line detection and a little ultrasonic sensor on the turret and a TV remote. And these all come in the class pack and are also sold separately items if you have just bought a few individual Cyberbots. And then there's other sold separately items like the gripper that I just demonstrated, and there's some special servos that know where their rotational position is. They have built-in rotation sensors, as opposed to the normal motors, which if you want the robot to go straight forward, you have to adjust possibly one of the wheel speeds to get it to go straight forward, because it might lilt to the left or right, which is common with the kind of motors that this robot uses. So there's upgrade motors that have the built-in rotation sensors, and the script has features that will tell the motors to straighten out the path for you. Okay. There are also cyber security tutorials, and there's a Python cybersecurity series that's official, but what this is really just certain lessons from the Cyberbot. Of course, it's organized by, here's the computer science prereqs, and then here are the lessons: communicating over radio, with a chat, with data exchanges like the ones for the tilt-controlled gripper bot, for example. And then we get into how to encrypt messages, how sniffing attacks can end up seeing unencrypted messages, and then how encryption can fix it. Likewise with brute force, how to make strong passwords for your encryption, and then how to deal with packets that are delivered by a malicious party that can crash your robot or microbit application. If it's looking for certain kinds of radio messages, there are ways to, for example, disable somebody else's microbit by sending them a packet that has bad data in it, and how to adjust for that, which has a lot to do with exception handling. And then, of course, for more reading, there's the AI book, which I mentioned, or which I've already talked about. So remember, this is its own thing, but it all came from the Cyberbot tutorials. So right now for Make Code, we have a subset of those lessons. So there is there's a fair amount of cybersecurity in the Make Code. So after the basic robotics lessons, there is the radio basics, radio data, and then encryption, and currently just the brute force. I am assuming that more of the cybersecurity will appear here. This is what we have right now. The Make Code is a very recent release for us. We just released it this month. And so I think that as the months go by, you might see more cybersecurity material here. as well. So anyway, there's a cybersecurity link, and then the MakeCode cybersecurity material is all in with the CyberBot currently. And then I just included a few articles about cybersecurity that you're welcome to take a look at just to get an idea of how and why one would use the microbit for cybersecurity. And it has to do with the Internet of Things. And so the microbit is really nice for that, since it's got the little built-in radios and the ability to exchange data with other microbits. So you essentially can make a little microcosm of a network or even of the internet, and then teach cybersecurity that way. So for cybersecurity, there's computer science prerequisites, and then there is the main lessons, and then there's some optional throwing robotics in there as well. And then same thing, but there's a little bit more in Python, where we have our computer science and programming prerequisites followed by the main cybersecurity topics. Another enhancement is a breadboard attachment, and this is for sorry, folks, I didn't put the link on here. So we'll go, first of all, I want to clean up my tabs, and then we will go to learn.parallax.com. And this time it is what's a microcontroller with Python and the microbit. Copy link address. So first off, I'll paste it into here. And I'll paste that one into the chat since it's on my clipboard. And so here's what's a microcontroller with the microbit. And there are some prerequisites. It's the usual getting started and writing microbit programs. There's also computer microbit talk, which is how to essentially use the serial monitor that's introduced initially in the getting started part. There is an entire, oopsie, went to the wrong page, sorry. Get started with the microbit and Python. Okay, here we are. So this is the one I showed earlier where you flash scripts, adjust them, save and reopen. And it also talks about the side panels a little bit. Use the serial monitor is the last one. And what it shows is right down below where your script is written, there is a little serial monitor that you can open and close. So for example, in Python, if I wanted to do the serial monitor, I could say print and then put hello in quotes. And when I run that, I can hit show serial. And sometimes it doesn't show up. Let's try running it again. And sometimes it gets a little funny. If it ever does this to you, there's 3 dots over here in the lower right corner, and there's a send control C for REPL. And then after you've done that, if you send a microbit again, now we see our messages from the script in the terminal. So that's a good to know little fact. Again, 3 dots, send control C for REPL. If it hangs up and doesn't display the message on the first try. And I believe that is mentioned actually in the intro video and the intro instructions. Let's see if it's down at the bottom here. Okay, no, it's not. All right. Here we go. Yeah, so it's suggesting send control D to reset and then resending. So that may also work. I've always used the control C for REPL. A REPL, by the way, is a Python thing that allows you to type in commands one at a time. So like if I go send control C for REPL, then I can say print hello in here, and then it prints hello. So that's an example of one Python statement at a time. That's what REPL is about. All right. So back to the electricity and electronics lesson. I got off on a little bit of a tangent there, and I'm sorry about that. This is a kit that which has an accompanying textbook, as with all of them, an accompanying online textbook. And this particular kit introduces the breadboard, which is this little set, or this set of boards with sockets, and it shows how to build circuits on those. And so here is an example of putting together your breadboard. And it's showing, in this case, how to identify where to plug in the adapter. And it's showing step by step exactly how to line up the pins that are sticking out of the underside of the adapter with certain numbered sockets on the breadboard, and then inserting it into the breadboard, and now you're set up, and the microbit will be able to control and monitor certain circuits that you build on the breadboard. See here. And as it continues, here's an example where you're actually building a circuit step by step, and it's showing the schematic elements on the left and an actual physical implementation on the right. So I skipped a bunch of material. For example, it introduces this part called a resistor and that part called a LED or light emitting diode. It basically goes through a lot of beginning electricity and electronics, including stuff where equations are used to calculate current, resistance, and voltage, and to measure current, resistance, and voltage. And it even has an accompanying voltmeter / oscilloscope. Let's see here, cyberscope.parallax.com. And this is used to measure many of the circuits that are created. The microbit is actually measuring and sending the data. And in the interest of time, I will just play you a few excerpts from the demo video. So it basically shows how to run the demo, but later on in the video, it shows and this is demo mode. But what this is doing is it's making virtual oscilloscope measurements. If you follow through the chapters of the What's a Microcontroller, you will actually use the microbit to take physical measurements, and you will see similar graphed responses. And for those of you who are familiar with oscilloscopes, we just saw setting the trigger, which is the time that an event is displayed on the oscilloscope. And then these are multimeter measurements, which are also taken. It's where you probe a circuit to measure, for example, the number of volts across a particular component. You can also measure a part's resistance as well as the amount of current passing through the circuit. So, and we go through lights, push buttons, the servo, and then there's also some potentiometer material. These are the electricity and electrical measurements, which covers Ohm's law, and it covers measurement units and stuff like that. How are we doing for time? Okay, managed to get a little bit behind here. So the final topic we're going to talk about is student versus, student and teacher resources. And so the first one is where to get microbits, robots, and other stuff. That would be at parallax.com. So I'll go ahead and enter the address. For some reason, it's not showing up. Let's see. I don't know why the links are not showing up. They should be embedded. I apologize for that. Okay, so www.parallax.com. Shop. So there's Cyberbot along the left, and there's also going to be Microbit, which is inclusive of Cyberbot. And so one of the important ones is, or a couple of some of the important ones would, like, here's the What's a Microcontroller kit for the electronics. Here is a 10-pack of microbits at $175, so that's $17 per microbit. So I'll put that one in, or actually I'll put the microbit product category in first, paste, and then the microbit club bundle. I'll see if I can find the microbit go bundle, which is a single unit of microbit. Here it is. Copy link address. So this is the $18 single microbit. And we also saw, for example, the robotics kit. I saw that up a ways. And if you have a class set of microbits, you can upgrade to the Cyberbot with the no microbit version of the Cyberbot. And then there's the microbit included version of the Cyberbot, which is right here. Copy link address, paste. So that's an example of where to find microbits, Cyberbots, the What's a Microcontroller kit, and all that. So here is the link, product category microbit. That's one I pasted in earlier.
So if we're planning on buying all-inclusive, we should buy a Cyberbot.
Yes. Yes, because the Cyberbot includes the microbit. Now, if you want to do tilt control, there's a couple of ways to do it. One is that you could simply use a second Cyberbot. So you could pair up students and have one student tilting their Cyberbot to control the other Cyberbot. Or you could end up getting a second set of, an extra set of microbits. So for example, you could get a class pack of robots. So let's see if, and then a class pack of microbits. So if I go back to www.parallax.com, shop, and then here's microbit. And so here's the Cyberbot class pack. And that's the one that has extra things. It's got line following sensors, ultrasonic distance sensors, TV remotes for a different kind of remote control. And that's all included in the class pack, along with rechargeable batteries and a battery charger. And then if you wanted to have an extra set of microbits to be potential tilt controllers or just used on their own, than the microbit club bundle that I pasted in earlier. So here's the club bundle, and that's one where you could essentially add on microbits on top of the robots, or just, you know, use the microbit in the robot, because it's pretty easy to plug it into the robot and then remove it, but it doesn't have the extra battery pack and things like that. So the both the club and the go, which are just the 10 pack and the individual versions, have built in or have in the box, they come with one pair of batteries, just alkaline disposable batteries, and then a battery pack and the small programming cable, which you won't need if you've got the robots, because you've got a nice long programming cable with that, and of course the microbit. And then again, there's a with and without version of the robot with and without the microbit. Okay, another thing is we've looked a lot at the student lessons. Now let's take a look at the teacher resources. And so this is one where you have, as an attendee, you've already signed up to be an educator at learn.parallax.com, or you will have just received an email saying, hey, we've created an educator account for you, and it'll have some login information. And so as a student, you can still get to this educators area, but there's nothing that has solutions or additional material for the students to work through. So if we go to Cyberbot resources right now, sure, we've got the strategy guide, we've got a standard matrix. This is all published and out in the open, but you have to log in order to get to the assessment materials. And so if I'm going to do this in an incognito window simply because that way I can continue to demonstrate stuff without being logged in as a teacher. So I'm going to go to learn.parallax.com in this incognito window. Again, you don't have to worry about this. I'm just doing this in an incognito window for convenience, so that I can have my educator opened up in this incognito window while the rest of the windows will still behave like I'm a student. Okay, and then off screen, I have to basically log in here. Okay, sorry, it takes me a second to do this. Still working on it. Okay, educators. Log in. I should have thought to do this during break on the incognito window. And then yeah, the reason it's taking me a while is because I'm wrestling with my password manager. Almost there. And back to the educators page. Okay, so before I bring that browser over, I just want to show you that there's a login link here, but also when you go to the educators section, there'll be a login link right at the top. So here we are back in Cyberbot resources. Again, I can't get here as a student, but in this other browser, I have now logged in. Well, yeah, I am logged in. You can see that. And so now, if I go to, for example, the Cyberbot resources, now the assessment material link is live because I'm logged in as a teacher. And so I can follow one of these, like maybe the whisker contact. How about navigation with the Cyberbot? Okay, and I can download the zip of all that. And then looking in my downloads, so here is an example of one of the worksheets that's available for a given chapter, along with the answer key at the bottom in red. So that's teacher resources for you, and you're all able to get in now. We've also got some upcoming workshops. That's at parallax.com/category/events. And coming up is going to be, so this is the microbit for beginners, and you can go to view event and see that. As soon as it's done, one thing that you're going to see is that it will appear down here in the on-demand workshops. Because we have a brand new site, some of the links have changed, so we temporarily took down the previous incarnation of microbit for beginners, and we're going to use this one for on-demand self-paced workshops right now. All we have for that is the Arduino Shield robot down here, but that's one that's really good also. I encourage anybody who wants to teach their students C programming to try that one out. And if you qualify, you will receive a free Arduino Shield robot to go through the activities with. You can also look at past events where you'll see some of the previous workshops, as well as a number of other fun things to check out with Parallax microcontrollers. Okay, so I really should have talked a little bit more about the actual events. So I'm trying to get back there. Okay, here we are at the events page, and we're going to go to Educator Workshops. So upcoming events, we've got a cybersecurity event next week. If you have, I believe this is closed, but if it's especially important for you to take this, I might get in trouble for volunteering this, but you can probably reach out to us if you already have a pair of microbits. You will need 2 microbits and 2 programming cables for this one. And so if you already have those, we might be able to shoo you into the event. Otherwise, this is an example of another upcoming event that will also become a self-paced event, and it will appear at the bottom of the events page. So after this event is done, it will be added to the self-paced workshop events as well. Then we have a Cyberbot workshop that you can still sign up for. It's coming up on March 3rd. This is a 3-session event. So it's going to be 3 2-hour sessions starting at 3 p.m. Pacific time on March 3rd, 5th, and 7th. And after this one, there will also be a self-paced version available. Okie dokie. There are some more slides here. We're 5 minutes over, so I'm just going to let you know that there are slides. The Microbit Education Foundation has a curriculum that it makes available. It's kind of light. It's a lighter curriculum than what's on learn.parallax.com. So here's the computing fundamentals, and there's teacher materials. There's similar stuff to what I've shown. And makecode.microbit.org, we've seen lots of. But if you scroll down in makecode.microbit.org, you will find other curricula. For example, there's a computer science curriculum. It's a really large download. It's hundreds of megabytes. And that's the intro to CS Online. So if you go to makecode.microbit.org and then scroll down, look for Intro to CS Online, and there's a classroom version of it where you can download the teacher materials. Then we looked at this earlier. This is the Make It Code It site where we had examples and we looked at the step counter and the beating heart. Again, this is a great place to get started. Then learn.parallax.com with its student and teacher resources. That was an earlier slide. Let me see if I can find it. Uh-oh, screen froze. It's back. So learn.parallax.com. It's got the student lessons and then the teacher resources by going to the Educators tab and logging in. But the student lessons are all right up front. So again, learn.parallax.com. This is the home page is the student lessons. And so, for example, in Python, we can go to Cyberbot, and then we get these. And then if we go to Cyberbot up here, we have both the MakeCode and the Python versions of it. These are entire textbooks. And then again, if you go into one of these prerequisites are a textbook that is covering lots of good computer science topics. And again, when you go to the Educator resources, then there's assessment materials that accompanies it. And so that is a step up from Make It Code It. And then there's more items on the Parallax website or the learn.parallax.com website. Again, the cybersecurity, the AI lessons, the Cyberbot lessons, all available without any special requirements. And then, of course, the assessments are for you, the teachers. Here is our contact information slide. So if you need to get with us, there's an educator hotline that you can call, especially if you're stuck on something and your students are waiting to get unstuck. Try the hotline. You can also use the hotline, though I recommend using sales line to get to a salesperson if you're needing to buy microbits or Cyberbot robot kits or anything else. You can reach out to sales@parallax.com. That's where to go for purchase orders, although you will also get shunted to them through the hotline if you ask there. We have education@parallax.com. Our entire education staff will see this, and the best person to answer your question will jump in. So I highly recommend this for general questions or for what should I get to teach subject X. Those kind of questions, or hey, I'm stuck on something, but I have enough time and I don't need to call the hotline. Again, education.parallax.com. It's a terrific resource. And then we also have forums and a Facebook page. And so those are all places to look for Parallax and Microbit and Cyberbot stuff. And that is the end of today's workshop. Thanks everybody for coming. We'll be sticking around for a little while for some questions and answers that are unrecorded, so you can go ahead and hang out if you want help getting your microbit connected to your computer, or have some more questions about anything that we've talked about today, or even other microcontroller topics in general. Anyway, again, thanks for coming, and we can go ahead and stop the recording now.